Hello, and these are my test corrections for exam number 2. First off, we're going to start with number 2. The correct answer should be B, because histidine acts as a base to remove a proton. So if the pKa were to increase, it would become protonated, not deprotonated. Therefore, the enzyme activity would decrease. When we're looking at number 4, it should be isoleucine. Because isoleucine is hydrophobic, it will work with the phospholipid bilayer, and therefore it can act as an integral protein, allowing other molecules to pass through. For number 6, which should be letter A, it's stabilizing the transition state, so like the boat or the half chair, anything like that. When I was first looking at it, I thought it just said binds tight to the substrate. I didn't really read the first one, so it should be focuses on the transition state. The 7 here, the apoenzyme, it should be the hollow enzyme, so the apoenzyme is only when it's part of it, not the full complete subunits and groups. Number 8, I just read it too fast. It's flipped. The Km should be over the Vmax for the slope. Number 13, it should be C, the covalent attachments of the phosphate groups. The phosphorylation is regulated by the kinases, and because of that, the covalent bonding is very reversible and it's very fast. So it can happen often and doesn't really take a ton to make it so irreversible. Number 14, it should be aspartic acid rather than the A. So the aspartic acid's whole role is to support histidine and make it a stronger base, because histidine needs to be able to remove the hydrogen. So that's what that does in the 3 complex. So aspartic acid, histidine, and serine, they all work together. That aspartic acid is going to be supporting histidine. For number 15, I read the question wrong. I thought it said which is not an epimer of glucose. So glucose, that's the normal molecule there. So C is not, because it's different at 2 spots, not just the 1. So you can see with A, B, and D that it just differs at the 1 spot. For here, I was off on my calculations for 18, so it should be 1.3 to the -4 rather than -5. I think I probably was just going way too fast. For 20, that then messed me up, so the proper formula is the Kcat times the substrate Km over Km plus the substrate. So fill in the values that we were given, you get the Kcat. Then to get the efficiency, it's Kcat over Km. So that proper answer should be the 7.3. And then for the 19, again, we're calculating, and I think I was off on my conversion, so it should be the 44,000. 32, I just needed to explain a little bit more. So this folded sheet of the beta 1,4 of cellulose is going to be arranged parallelly to create this really flat, nice structure, which looks like this, and then kind of protects against these grit outer portions. So really thick, nice, good layers against everything. For the glycogen, the way that it's set up, it provides lots of spots where enzymes can break down the molecule more quickly. So if we look here, say the black is the glucose, enzymes can come together and easily get that glucose for fast release of the glucose. Number 38, it's silly because I wrote it on the next question, the beta 1,4 of cellulose. I just didn't really think about it. So the correct answer should be the beta 1,4 because it's similar, or it's found in cellulose, and we can't break that down. And that's the same thing over here. We can't break down the the cellulose bonds. So our alpha, beta, 1, 2 are in sucrose, and we're able to eat that. For 41, I was off by a factor of 10, so it should be 25 kilojoules per mole. And then for the last one, I got it wrong. I didn't get any feedback as to why. So these are the D-glucose and the D-mannitol. You can just kind of see where they're different there. But yeah, those are all my exam corrections. Thank you so much.